So we've added and subtracted fractions. We've done that already. And now we're going to add and subtract mixed fractions. So it adds a little bit of a dimension to it, and you can kind of look at it in one of two ways. Method 1, I think, is actually harder than method 2. And you're like, well, then why did you call one method 1 and one method 2? Well, probably because as people get higher up in math, they like this idea of changing things to improper fractions first. So it happens more often, and it becomes like a method people go to the best. However, method 2, when we do it, is going to get us the answer probably a little bit easier. It's going to make your times table a little bit nicer too, so we'll see the difference when we look at both methods. First of all, when I have a mixed fraction like 3 1/3 and 1 1/4, your first thing I want you to kind of think about is an estimation of what this is going to equal. 3 1/3 means I have 3 and a bit. And I add 1 and a bit. If you were estimating, would it make sense that you would have 4 and a little bit more? Like you have 3, a little bit more than 3, and a little bit more than 1. You're going to get 4. Maybe you'll get up to 5. Maybe not. We'll see. But first of all, get an idea of an estimate of what your answer should be. Because in the end, you'll be able to say, hey, I think my answer makes sense, or my answer doesn't make sense. So method 1 is a good review because we have to change things to improper fractions. So 3 1/3 is equal to something over 3, and 1 1/4 is equal to something over 4. How are we for remembering how to do this? Okay. So again, if we do a review, we could say the steps that we did. We're like, okay, 3 whole ones times 3 is 9, plus 1 more piece would give me 10. 4 times 1 is 4, plus 1 more piece would give me 5. If we wanted to visualize this, this is like having 3 and 1/3 of a chocolate bar. And if each of those chocolate bars was also split into thirds, each chocolate bar would have 3 pieces. 3 times 3 is 9, plus the 1 extra piece gives you 10 pieces in total. So we get that idea and review that idea as well. But what you guys want to get to is you want to get to that point where you're like, okay, I get the idea, but I don't want to have to draw out the idea every time because that's going to take me more time. Now that I get the idea, does it make sense to me how to do this quicker? Am I going to be able to remember that? And once you have it as improper fractions, now it's a review of what we were doing before. In order to add things together, the pieces have to be the same size. So right now, my denominators are 3s and 4s. I want them to be the same. Can you see in your times table a number that's both in your 3 times table and your 4 times table? And can you pick the smallest one if possible? 12. Excellent. So I want these to be 12s so that my pieces are the same size, which means I need to multiply this one by 4. And this is review. If you multiply the bottom by 4, we multiply the top by 4. And this one by 3, so we multiply the top by 3 as well. And then on the top here, 4 times 10, that will give me 40. And 5 times 3, that will give me 15. Add these together, because now the pieces are the same size. 40 plus 15, 55 over 12. Or, if we wrote this as a mixed fraction, count by 12s. 12, 24, 36, 48, 60. Okay, 60 is too high. 48 of them would be 4 full ones. And from 48 to 55, on a quiz or a test, I would say either of those are good answers. If I was going to do more math, For me, I would keep the improper fraction. If I was wanting my math to mean something, I like the mixed one. You see that you have 4 and 7/12. That sure looks like it seems reasonable as a final answer, because I had 3 and a bit, and 4 and a bit, and 1 and a bit. I should get 4 and a bit. That makes sense. That's method 1. Method 1 is really good for reviewing changing to improper fractions and reviewing just adding regular fractions. But as I said, method 1 gets bigger numbers. So sometimes, especially with our times tables, as they get bigger, I notice that's when you start to struggle a little bit with the numbers. So method 1 could be harder. Method 2, just adding things separately. Because 3 and a third means 3 plus a third. And 1 and a quarter means 1 plus a quarter. And you can add the 3 and the 1 together really easily. 3 plus 1 is 4. And again, we're going to want our fractions to have that same common denominator. Same idea as the other side. I multiply this by 4, and this by 4, and this by 3, and this by 3. But the nice thing now is my numbers are really small. The 3 plus 1 is 4. The 1/3 is 4/12. The 1/4 is 3/12. And we get 4 and 7/12 that way as well. And I've seen sometimes people do this, but they write the 3 and 1/3 as 3 and 4/12. And they write the 1 and 1/4 as 1 and 3/12. They write it like that. And then they add the big numbers together in 4 and add the fractions together. And get the answer that way as well. Whew! Method 2 was the biggest number we had to deal with. Ooh, like 4 times 3 is 12. Okay, that's why method 2 is a little bit nicer, because numbers stayed smaller. Here we had like 4 times 10 is 40. We had 55, which was harder to write as a mixed fraction. Yes.
Can you explain it?
I can explain it again. Which method do you want to start with? Both of them?
Method 2, I usually.
Okay. So method 2, I broke up the 3 and a third, because 3 and a third means 3 plus a third. And I broke up the 1 and a quarter as 1 plus a quarter. And then adding 4 things together, you can decide what you want to add up first. So I decided that I'd take the 3 and the 1 and add those together, because that's really easy math, right? 3 plus 1, that's 4. Then all I had left to add was my fractions. And again, for adding fractions, we need that common denominator. So I looked at the 3 and the 4 in my times table and said it has to be 12. And I changed the 1/3 to 4/12 and the 1/4 to 3/12. And then those pieces are the same size, so you could add the 4 plus 3 together to get your 7/12. So you see that work? Yeah? Okay, awesome. Thank you. So we're going to do another one together. Which method do you want to do first? Method 1? You like things in order? Okay. We'll do both methods again. We'll start with method 1, which meant we want to write these as improper fractions. Do some mental math in your head first. This is a great strategy for learning math. Okay? First of all, the greatest strategy in math class is try to pay as much attention as you can while you're here. You have to be here for an hour. Like, there's not really anything you can do about that. You can have that hour really help you with your math, or you can have that hour not help you with your math. At the end of the day, whatever you do helps yourself, and that makes you better for the rest of your life. Right now, I'm changing these to improper fractions. Before I write the number down, you can choose to be a passive learner and just copy things down, or you could also choose to try to predict. I'm changing this to an improper fraction. Since we've done that before, did you get 17? Check. And if you did, perfect. And you can maybe do it, like, sometimes people are like, but I don't want to write it down, Mr. J.R., because I don't want to write something wrong in my notes. Okay, then do it in your head, or do it off to the side. But come up with something on your own first, because then you're checking as you go. Do I get this or don't I get this? 2 1/4, 9/4, right? Because 2 whole ones would be 8 pieces, plus 1 more piece, 9 pieces. What's my common denominator going to be? You put your times tables with 4 and 5. And again, I'm pausing on purpose. Did you come up with 20? And if you did, feel good about that. How do I get 20? Well, I have to multiply that by 4, which means I have to also multiply this by 4. Now, on an actual test, I'm going to expect you to know your 10 times table. I'm not going to expect you to know your 17 times table. I'd still expect you to push yourself. See if you can do that in your head. But if not, I would give you a calculator to do 4 times 17. And what do we get? 68. 9 times 5, that one I would expect you to be able to do. 45. $68 plus 45 is 113 over 20. Ooh, recommendation. How many people have their own calculators? Okay, good. If you don't have a calculator, for math class, you are going to need a calculator. I would highly recommend getting a calculator from the school because it has some nice options on it. 113 divided by 20 comes up as a decimal. Can change it to a fraction, can change it back to a decimal on a single button, which is really nice. So when I hit the decimal button on my calculator, it tells me that it's 5.65. Since you'd be allowed a calculator on this question anyways, because the numbers are bigger, look at this, 5.65, which tells me a hint in my mixed fraction. I know that the whole number is a 5. So how many, if I do 5 20s, do you see that that gets up to 100? Leaving me with 13 left. So I get 5 and 13 20s.
I actually thought method 2 was really easy. It's funny because I've always done method 1 just because.
Well, it's method 1 is the one that you just, like, it works for adding, it works for subtracting, it works for multiplying, it works for dividing. So it's kind of a go-to because it works for everything.
Right.
But method 2, look at how much easier your numbers get.
Much easier.
Method 2, go up so I can see the numbers. I have 3 plus 2/5. I can even cheat and write the 2/5 here. And then, oh, I won't. 3 plus 2/5. And then I'm going to add 2 plus 1/4. So the 3 and the 2, that's easy, that's 5. And now, I want those fractions over 20 again. This one I have to multiply by 4 and by 4. This one by 5 and 5. 4 times 2, that's 8. 5 times 1, that's 5. And sure enough, I have 5, and 8 plus 5 is 13 20ths. We get our answer with a lot smaller numbers. Do you see that technically method 2, you wouldn't need a calculator? Like method 1, the 4 times 17, I'd be like, okay, I understand that we might want a calculator for that. But method 2, you wouldn't need a calculator. Okay. The third one, I want you to try. Okay. Try first on your own. And then I'll put up the answers in a bit. If you can try method 1 or method 2. Pick which one you want to try first. If you get the answer with one method, try the other method too.
I don't know. I'm confused.
Okay. Let me just pause the video here. As you are going along. So. I'll put up both methods.
It's just weird that I don't have mine in there.
Okay, let's see how you did on your own. If you used method 1, you needed to get improper fractions.
Do you rent these or sell these to students?
Sell them, they're only like $13.
These ones?
Yeah, like you buy them in the store for
And if
20.
I gave you 13, I would have to. Really?
But this button right here is really nice.
Yes.
Yeah. Okay, so using method 1, check your improper fractions. Were you able to say 3 whole ones would be 18 pieces plus 5 more would be 23 pieces. 2 whole ones would be 24 pieces plus 5 more, 29 pieces. Now we need a common denominator. 12 is the smallest, you only have to multiply that 6 by 2. So So I multiply those by 2, I get 46 over 12 plus 29 over 12, gives me 75 pieces in total. Which if I change that back to a mixed fraction is 6 times 12 is 72. So I have 6 full ones and 3 pieces left. And the 3 over 12, both of those can be divided by 3. So in lowest terms, we would write 6 1/4. If I wanted to keep it as an improper fraction, I'd also have to notice that I could divide each of them by 3. And it becomes 25 over 4. If you have a nice scientific calculator, right? If you go into here right now and just type in 75 over 12, it'll either give it to you as a decimal or it will reduce it to the 25 over 4 for you, which is really nice. Method 2, if we're adding things separately, 3 plus 5 6 plus 2 plus 5 12, so 3 plus the 2, that makes 5. Again, I want a common denominator of 12, so I multiply that first one by 2. But interesting in this one, my 10 over 12 plus 5 over 12 gives me 15 over 12. So it's not wrong if you said temporarily, this is my answer, 5 and 15 over 12. But 15 is bigger than 12. If you have 15 pieces and it takes 12 to get a hold, you see you have another whole one. 15 over 12 is 1 3/12. So that 1 can add to the 5 again, and we get 6 3/12, and it can get reduced to 1/4 again. Now, generally in subtracting, you'll see people recommend the improper fractions just because you make less mistakes. I will still show you both ways for this. Okay? So, method 1 generally is seen as better, but I'll show you both ways. So I have 3 1/5 minus 1 3/4. 16 pieces there, 7 pieces there. Hit your common denominator on 20. I'd have to multiply this by 4, and this by 4, this by 5, and this by 5. Okay. Test your times table. 7 times 5, that one you should do.
35.
That is 35. 4 times 16, that one wouldn't be, that one you could use your calculator for. Although try it in your head.
29.
And now 64 minus 35.
29.
You're going to be left with 29. Sometimes what I do is once I get my answer, I just do a quick check. Is 29 plus 35 64? And this is 1 9/20. So the subtracting. The reason the subtracting is a little bit harder with method 2. Because you have 3 1/5, and then you're subtracting 1 3/4. You're subtracting the 1, and you're also then would subtract the 3/4. So this is the first thing that I find that sometimes students make mistakes on if they try method 2, is they forget they're subtracting all of 1 3/4. That means you're subtracting the 1 and you're subtracting the 3/4. Now 3 minus 1, that's easy, that's 2. We get our common denominator of 20. And here's another place which sometimes gets a little tricky. So I'm going to multiply by 4 and by 4, multiply by 5 and by 5. And I would get 4/20 minus 15/20. Ooh, mental math. What do you get if you have 4 minus 15? Now we're on to our number line again.
Minus 11.
Minus 11. So we can't just combine this, like adding it's easier because you could just say, in the end, say, hey, combine it as your mixed fraction. But now I've got subtracting. I have 2 minus 11 out of 20. How am I going to do that? Well, this is going to leave me with 1 left and 9 20s. Sometimes students think of this. If 2, they change this. They change it to a common denominator. 2 is the same as 40 over 20, and then subtract it. But in this case, I'm going to say for subtracting, generally method 1 is better.
Father, may you have the question, please?
So I have a couple for you to try. So there's 2 questions. Try them both with method 1. See what you come up with. Our second one here.
Yes, because this is gonna go. This can get a little bit tougher.
Yeah.
Getting nice and quiet. Just a little bit of wandering today. Not locked in. Okay. Yeah, I did that on one of them and I caught it. And I had to go back.
Okay, check your work on this one. This one goes into the negatives. So again, it's practicing a bunch of stuff we've looked at already.
This is gonna be.
Subtracting a negative is the same as adding. 3 1/3, 10 pieces. Common denominator would be 12.
I would clear this. If I
Multiply by 3, multiply by 3. Multiply by 4, multiply by 4.
good.
Negative 21 plus 40.
Now this is just what number can you put this
One page is the answer, so you can check them at home to see if you're getting them right.
Oh, is this how one?
This is, well, we're gonna see what you get done. We got 10 minutes left, so I think you'll get a bunch of it done. That will not help you learn anything, and you'll just be screwed for the rest of your life. But go for it.
I'm not even talking.
To get to a negative, you put the number first.
Both papers are for you.
Oh, okay.
One is the answers.
Okay.
Check the answers out. I'll look at it.
All I did was wanted you to do.
Check the answers after you.
Yeah, okay. So, we have
is mine.
About 12 minutes left in class. I gave you the questions. The second sheet is the answers. And Dayton says, well, what if I just copy them? I'm like, if you just copy them, it's gonna help you nothing whatsoever. And you're gonna get to your test and you're gonna get screwed. And then you get the wonderful opportunity to take grade 9 math again next year in grade 10. Not very much fun. What you wanna do when you have the answers is you wanna try it on your own. Do one. Check what you get. See if you got the right answer. If you get the right answer, maybe do 2 on your own. And then 10.
Wait, are these?
These are the answers to these questions.
All right.
And whatever the last one is, depending on where it's written.
Let me just go.
And they show some of the work so you can check
First off,
check how you're doing. They're using sort of a method too in the answer key.
are you pretty good with getting these mixed factors?
Yes, this is good. Yes, this is good.
This is what I would rewrite it. I've got
So the 5 tells me 3 is 15 full pieces plus 3 more 18. Now we need to make these two numbers the same. So if I want to make them 10s,
and then I would just,
Have to
see how
multiply
much
that
this
one.
clears this all up. Now 3 times
so I multiply this one by 5 too.
plus 1 is.
This one I have to multiply by 2. I multiply this one.
Now just 10
And
because
that's how I
we
get
took care of this. Take
And how I
away
get
negative
36.
is positive. Now it's just 10 over 3.
Okay. So
Now this is like everything else. What number can
we
both
could,
base
if you like this method,
Perfect.
so this one will be over 2,
And now
7.
I have to multiply by 3. So I do that too.
Because 3 would be 6 pieces plus 1 more 7. The 4, this would be 4 times 2, this would be 12 pieces plus 2 more. 14.
Negative 21. Now, this is where your calculator
Then,
is just do negative 21 plus 8, which now
I need them 6 pieces.
and that's you showing your work.
I did it all.
Yeah.
Yeah. Plus 28?
So, but now pretty good. You see that? The brackets.
What
are-
number is closest to 49 and
Because
6
it's
times 50?
taking away negative. That's a great question. So, yeah, and that's why I'm like, oh, I'm taking away a negative. Remember that negative 3 1/3 is just, it's a negative fraction.
Closest to
The whole
46
thing
times
was,
what?
oh my God.
6 times, how many numbers?
Say that again.
7. 6 times 7 is 42.
Plus,
If I do one more, 6
yes,
times
then
8
you're
is
adding
48.
negative.
So if I do
And adding
8,
negative is basically just.
that's 48 pieces, I have 1 piece left.
So yes, it would be taken. Yep, that's good, and you keep asking questions, and you know what that tells me is how to fully conceptually understand this. Which means you're like really close to fully getting it.
Yo, so on this, how do you know what the multiply about? These two can't really have it.
Oh, so first off, I need to know which way you like. Do you want to
Method
deal?
2.
You like method 2. Okay, so then what I would do, and what he's done, is right off the top, he's showing you broken down. But you understand that we're basically gonna have 3